Subject of the video is preparation of an effective and applicable work schedule in BIM environment. 01 LOD definitions. Errol Muratti, Iraq Free District, born in 1961. Iraqi Turkmen by origin. Graduated from Basra University, Faculty of Civil Engineering in 1984. 39 years of work experience in construction site, technical, office, planning, and project management fields. Please take a look to my detailed resume file found on the link shown on the screen. Waiting with great pleasure for you to subscribe to my YouTube channel as shown on the screen. In the previous video, we talked about the design stage. In this video, we will talk about the connection between the work schedule and the design stage, which basically depends upon the quantity take of the construction items that will be calculated based on the data level of the design, so that the duration to be predicted based on the labor for each activity or construction item. We hope that these videos will be useful to students studying at engineering faculties and engineers working in construction design and fields, believing that they will make significant contributions to engineering and project management. As it's known, the design stage content defines according to the design data level, which is named LOD. For example, LOD 0 representing static process, LOD 100 representing concept drawings, LOD 200 representing schematic drawings, LOD 300 representing design detailing drawings, LOD 350 representing tender file drawings, LOD 400 representing application and shop drawings, LOD 500 representing as-built drawings. Every work schedule needs to be organized in an order at the first stage of its preparation, and this is called WBS, Work Breakdown Structure. The upper levels of this order include location, project, and employer informations, while the lower order contains construction item categories. At the past time before development of BIM, this order was organized at the construction item level according to the BOQ of the relevant project, according to the bit of quantities of the relevant project. But with development of BIM, this approach need to be changed since the work schedule can follow the development in the BIM environment in parallel. In parallel with this approach, the CSI Uniformat organization was developed for the layout of work schedules, so that just as the design can be monitored from the concept phase of the project to the delivery phase by having the feature of running the design stage in an integral manner with LOD. Work schedules also with the same structure can be monitored from phase to phase. Since the design data level, meaning LOD, is related to BIM dimensions, it is necessary to make some definitions regarding BIM dimensions. A BIM model can be used for specific purposes defined before the project according to the nature of the project or its purpose, generally known as use cases. And for this purpose, certain parameters are added to the existing information contained in BIM according to the project phase requirements and the complexity of the project. These redefined and used additions can be defined as BIM dimensions. These dimensions enable the data associated with a model to be developed at even greater levels to provide a better understanding of a construction project. It has basically evolved from 3D and 4D dimensions to 5D, 6D, and 7D dimensions. Being dimensions 3D, 4D, 5D, 6D, and 7D each have their own purpose and will provide guidance on how much a project will cost, the time for when it will be completed, and how sustainable it will be in the future. Beam dimensions brief descriptions 3D applicated three-dimensional XYZ structure 4D timeline scheduling and durations 5D cost estimation budget analysis 6D sustainability self-sustainable and energy efficient 7D facility management information 8D typically refers to the overlay of health, safety, and welfare consideration into the BIM process. 90 refer to when the focus on lean construction. 10D, which has been commonly referenced in the context of industrialized construction. It is observed that the beginning of an effective and applicable work schedule in the BIM environment simultaneously depends upon the level of development of the design lot. The BIM dimension 3D, 4D, 5D, 6D, 7D, and the level of detail of the measurements obtained from the existing drawings. Details regarding BIM dimensions, lot data level, and appropriate WBS obtained simultaneously based on them are available in relevant institutions in various developed countries of the world and can be consulted to obtain these details. Although it is said that we are developing and gaining ground in Turkey and similar countries, BIM-related databases can only be obtained from external sources, since such simple but vital studies are not available. The coordination between project phase, BIM dimensions, and level of development BIM at the project phase of conceptual design. All BIM dimensions focus on information handover, and the level of development is under LOD 100. At the project phase of schematic design, 3D BIM dimensions focus on options analysis. 4D BIM dimensions focus on phasing and scheduling analysis. 5D BIM dimensions focus on cost analysis. 6D BIM dimensions focus on investigation of suitable material, and the level of development is under LOT 200. At the project phase of detailed design, 3D BIM dimensions focus on 3D model site coordination, constructability analysis. 4D BIM dimensions focus on linking time and scheduling data. 5D BIM dimensions focus on linking cost data. 6D BIM dimensions focus on sustainability analysis, identify potential hazards. 7D BIM dimensions focus on preparation of safety plan, and the level of development is under LOD 300. At the project phase of tendering, all BIM dimensions focus on tender, and the level of development is under LOD 350. At the project phase of construction detailing, 3D BIM dimensions focus on shop drawings. 4D BIM dimensions focus on phasing and scheduling, clash detection, monitoring project progress. 5D BIM dimensions focus on cost estimation, quantity takeoff. 6D BIM dimensions focus on site managing using recycled materials, waste minimization. 7D BIM dimensions focus on maintenance and control the construction, and the level of development is under LOT 400. At the project phase of facility management, we have 7D BIM dimensions focus on maintenance management, inventory management, portfolio, and the level of development is under LOT 500. In general, according to the graphics observed here, the pre-construction phase will include conceptual drawings, LOT 100, schematic design, LOT 200, precision 3D modeling, LOT 300, while the construction phase will include the construction document, LOD 350, and fabrication models issue for construction drawings, LOD 400, and the delivery phase will include the as-built drawings, LOD 500. Thus, the WBS work breakdown structure of the project is prepared accordingly by the state organization. There are some minor differences in LOD definitions. Let's take a look at the differences between country standards, the main source being the USA and the UK. Relating to LOD 0, this is available only at UK standards and will include high-level strategic information such as project objectives and feasibility studies, rather than preliminary planning and decision-making. While the concept design LOD 100 is seen in the US standard, LOD 1, which is called preparation and briefing, is seen in the UK standard. A 3D mass model, basic geometric shapes, and location information considered as the location of the area, its boundaries, context, and building orientation, and spatial arrangement and relationships are available in both standards. Rough outlines of the system and components and high-level cost estimates are only included in the UK standard. While the schematic design LOD 200 is seen in the US standard, LOD 2, called concept design, is seen in the UK standard. Subjects such as further development and approximate measurement of the 3D mass model and assignment of relationships between building components, placement of rooms by developing spatial arrangements, main orientations of circulation areas, placement of building system as concepts, assignment of main materials and finishing coatings are available in both standards. The map systems are only included in the US standard at the conceptual level, and the rough quantity calculations are only included in the UK standard. While design development LOD 300 is seen in the US standard, LOD 3, called developed design, is seen in the UK standard. Here we see that both standards are very close to each other. Finalization of the 3D mass model by feeding it with parametric data, finalization of spatial settlement issues, high degree detailing of the main systems of the structure, detection of complex situation, and realization of coordination are available in both standards. The finalized cost calculations is included in the US standards, while the detailing of finalized materials and finishing coatings and finalized quantities for cost calculations are included in the UK standards. While construction document LOD 350 is seen in the USA standard, LOD 4 called technical design is seen in the UK standard. Besides model feed by documents, fabrication and assembly sections, detailed material and finish information and performance data for construction, generating shop drawings files and fabrication for all components and support of site and the fabrication process are available in both standards. Detailed construction sequencing and logistics information is included in the USA standard, while fully developed system and component with precise dimensions and the comprehensive coordination and crash detections are included in the UK standard. While fabrication and assembly LOD 400 is seen in the US standard, LOD 5 cold construction is seen in the UK standard. Fabrication and assembly instructions, comprehensive material and finish information and performance data for construction, generating shop drawings files and fabrication for all components and supports of site and the fabrication process are available in both standards. Detailed connections and construction sequencing is included in the US standard, while comprehensive clash detection and real-time data for construction monitoring are included in the UK standard. While as built Law 500 is seen in the US standard, Law 6 called on over and closeout is seen in the UK standard. As-built condition representing integrating with facility management software for ongoing operations, accurate and detailed documentation of all building components, equipment manuals, maintenance schedules and warranties, providing historical data on building performance and energy use are available in both standards. As understood in both standards, it shows that work schedules and building construction sequence are following the design, the quantity takeoff, and the cost activities according to lot definitions. In our upcoming videos, we will take a look at how to prepare an effective and prospectively applicable work schedule according to the BIM dimensions targeted at each project and relevant lot stage. Hope to see you and wish endless happiness.